If you're feeling confident with the first example that we had in our notes, you can skip this video and jump to the application question in video 3. But this one does require a little bit more of us than the first one did because we don't have a variable that's quite as easy to get rid of those 2 times like we did with the y in the first example. Now we can choose any one of these variables to be our target. For no reason other than I think it's probably the easiest, I'm going to target the x's because I can get away with just multiplying one of the equations one time to combine them so that I could get rid of the x's instead of having to do it multiple times. So for example, I can go ahead and subtract these 2 equations and that will get rid of the x's. I'm going to have to be careful with my subtraction with the negative signs that I have all over the place, but we'll make it. And then I'm going to take, in a second attempt, these 2 equations and combine them, but I'm first going to have to multiply that bottom one by 3. So we'll start with the easier task. I'm going to rewrite those bottom 2 equations. So I've got x minus y plus z equals 4. And then the bottom one is x minus 4y minus 5z equals negative 14. And so now, like I said, I'm going to have to subtract that bottom equation. And so we're going to have to be quite careful with our subtraction here. The x's, not a problem. Those are gone. But now it's negative y minus negative 4y. And so when we do that, negative y minus a negative 4y, that becomes negative y plus 4y. Well, negative y plus 4y is 3y. So we have to be careful to realize that we're subtracting the negative here, which turns it into addition. Same thing is true on the next piece. We have z minus negative 5z, so think of that as z plus 5z, subtract a negative, so it becomes plus. So z plus 5z is 6z. And then we have to do that one more time, 4 minus negative 14, so that becomes 4 plus 14, so we get 18. So we've eliminated x once. So now we're going to have to do it again. So we're going to use these top 2 equations this time, but again, in order to get the match on the x's, I'm going to have to multiply the bottom equation by 3 so that I can subtract those equations and get the x's to disappear. But the top one, I'm going to copy it as it is. So 3x minus 2y plus 4z equals 15. And then I'm going to multiply everything in this equation by 3. So I'm going to get 3x minus 3y plus 3z. And don't overlook it, we've got to multiply that 4 on the other side, so equals 12. And now once again, I'm going to subtract these equations to get rid of the x's. So if we do that, the x's are gone. We have that same issue only once this time where we're subtracting a negative, so negative 2y minus negative 3y becomes negative 2y plus 3y, which is just y. Now it's 4z just minus 3z, so that's just going to be z. And then finally 15 minus 12, so we get 3. And so now we've gotten to a place where we have 2 equations with the same 2 variables y and z. So just like we did before, I'm going to port over here, and so we've got 3y plus 6z equals 18. I've got y plus z equals 3. And so now we can go ahead and use substitution if we want to, or I'm just going to go ahead and multiply everything in this bottom equation by 3 so that I get the y's to match up, and then I can subtract the equations one more time. So if I do that, I'm, in the interest of space, just going to do it right below. So I've got 3y plus 3z equals 9. I'm just going to lightly draw a line through that so we can kind of ignore that. And so now I'm going to subtract this top equation minus the bottom one because that's going to get rid of the y's. So my y's cancel out. I've got 6z minus 3z is 3z, and then 18 minus 9 is 9. And so now from 3 variables and 3 equations to 2 variables and 2 equations, we're down to just 1 variable and 1 equation. We can divide both sides by 3, and we get z equals 3. So there's 1/3 of our answer. I'm going to go back to, and actually I'm going to sneak in right here. Before I multiplied everything by 3, I had a pretty simple equation. We had just y plus z equals 3. If I kind of write over that so we can see it again. So I'm going to replace the z with a 3. So I've got y plus 3 equals 3. Hopefully it's pretty clear that we're going to end up with y equals 0. If I subtract 3 from both sides, I get y indeed equals 0. So that's 2 of the 3 parts of our answer. And so now I'm just going to go back to any one of the original 3 equations. Looks like this middle one, before we multiplied it by 3, is pretty simple. No coefficients to really deal with. So I'm going to have x, we'll go ahead and do that in green, x minus 0 plus 3 equals 4. Well, that 0 just disappears, so we're really just looking at x plus 3 equals 4. If we just subtract 3 from both sides, or even just look at it at that point, hopefully we see that x equals 1. And so then our ordered triple on this one is going to be 1, 0, 3. So this one just took a little bit more effort at the outset when we were trying to identify which variable to get rid of. Once we were able to just add the bottom or subtract the bottom 2 equations, but then to get rid of that same x variable a second time, we had to multiply one of the equations by 3 to get it to match up with the coefficient. But otherwise our process was essentially the same.